Section 2.6, Example 3, Solving Inequalities Analytically. So here's a quadratic inequality. 2x squared is less than or equal to 3 minus x. We're going to start by moving all of our terms to the left with 0 on the right. So we have 2x squared plus x minus 3 is less than or equal to 0. Now we're going to factor it and find the zeros. We've got our little graph over here too, so that's what it's going to look like. But that would come after we know what the zeros are, so we can mark those in as x-intercepts. Okay, so here's our factors, 2x plus 3 and x minus 1. Let's just check that these factors are correct. 2x times x is 2x squared. 2x times negative 1 is negative 2x. 3 times x is 3x, and 3 times negative 1 is negative 3. So then our 3x and negative 2x add up to our 1x in the middle. If you're not sure how to find those factors that way, I just did these by guess and check, but you could also do it factoring by grouping like we've seen several times in this course already. Okay, now we take those those factors, and we set them equal to 0, and we find the zeros, negative 3/2 and positive 1. Let's go ahead and start setting up a number line with those zeros and mark them as zeros with zeros above them. And now that we have that visual of the zeros we're working with, we can create our intervals for our chart and test values. So here's our intervals from negative infinity to negative 3/2, from negative 3/2 to 1, and from 1 to infinity. And notice how I've put brackets around the zeros because our problem is less than or equal to. So equal to means it would include the zeros in the answer, and that's what the brackets mean. Alright, we're going to start choosing test values in each interval. So less than negative 3/2 or negative 1.5 could be negative 2. And then between negative 3/2 and 1, 0 is a really nice option. And then bigger than 1, 2 is a great option. It's good to choose numbers that are as convenient as possible. So let's test each of those values, and keep in mind when we're done with this, we want our y values to be negative. So it's less than or equal to. That will be more important later. Obviously we can see our zeros listed on the graph at negative 3/2 and positive 1. Our parabola is going up because it's a positive coefficient. So the part where y is negative or below the x-axis is going to be between these two numbers. So it should be this middle interval right here. Let's go ahead and test these and make sure that that comes out correctly. Okay, so we take our test value of negative 2, we plug it in here. Negative 2 times 2 is negative 4, minus 3 is negative 1. And then negative 2 minus 1 is negative 3. And then negative 1 times negative 3 is positive 3. So that gives us a positive value, which is not part of our solution. Okay, let's try our next test value. Oh, yep, we've got our plus listed on our sign diagram. Okay, next value is 0. So 2 times 0 is 0, plus 3 is 3, 0 minus 1 is negative 1, and 3 times negative 1 is negative 3, so a negative value. So that one does fulfill the requirement for our inequality. And we can put the negative in our sign diagram. Okay, last we have our point at 2, so 2 times 2 is 4, plus 3, 7, and then 2 minus 1 is 1, so 7 times 1 is 7, and that is positive, which does not work to make y negative. It is not going to be less than or equal to 0. So, as we see, the only group that is less than or equal to 0 is this middle interval right here. So our solution is going to be the interval from negative 3/2 to positive 1, because only this interval yields a negative y value and fulfills the requirement of the inequality.